Hello. Today we are going to talk about experimental error analysis. It consists of two parts, direct measurement and indirect measurement. What is direct measurement? It's when you can measure some value directly, like a mass, length, time, temperature, by using some measuring tool or device. Indirect measurement, when you cannot measure directly some parameter or value. For example, density. You cannot measure density directly. However, you can measure mass and volume, and then using some tools or devices, and then you can calculate the density. Or speed, for example, you can calculate. You can directly measure distance. You can directly measure time, and then you can calculate the speed. However, if you have a device that can measure speed directly, then it belongs to the first part. Let's talk about direct measurement. Absolute error of measuring instrument or device can be calculated by this equation, where the total absolute error is equal to the absolute error of the instrument or device plus absolute error of scale. The absolute error of instrument or device is typically provided by manufacturers. If this error is not provided, that means it is considered to be zero. The absolute error of the scale is equal to the half of minimum scale division. If a device has a digital output, then the absolute errors of the scale is not considered. For example, if you want to measure body temperature with such medical thermometer based on mercury, you can check the absolute error on the backside of such thermometer, and it is 0.1 degree. And the minimum scale division is, as you can see here, it is 0.1 degree, meaning that the absolute error of the scale is 0.05 degree. So, the total absolute error is equal to 0.15 degree, which is the sum of these two absolute errors. The relative error can be calculated by this equation, where you need to divide absolute error by the value you measured on by thermometer. So here we can see it is 36.6 degree, which is normal temperature of human body. So the answer is 0.0041, or if you multiply it by 100, then we can know the answer in percentages, which is 0.4%, about 0.4% here. So the final answer should be written as 36.6 degree plus minus 0.15 degree and 0.4%, meaning that the error of our temperature measurement is 0.4%. Now let's talk about indirect measurement. If indirect value, let's say A, is defined by multiplication or division of direct values, let's call them N and M, then the relative error is equal to sum of relative errors of these direct values. And the absolute error can be calculated by this equation. There are some particular cases when indirect value is equal to direct value powered by some number. Let's call it S. In this case, we can calculate the relative error by this equation. If it is root, then we can use this equation. If indirect value, let's call it A, is defined by sum or difference of direct values n and m, then absolute error is equal to the sum of absolute errors of these direct values. And the relative error can be calculated by this equation. For example, let's calculate the density of a stone or small stones. For that, we are going to use the two tools. One is the electronic scales, and second is graduated cylinder. To measure density, we need to measure mass and we need to measure volume of the stones. So, how we are going to measure the volume? We are going to put some water here up to 40 cubic centimeters, and then we are going to put the stones and see, and the volume will be increased, and then the difference would be the stones volume of the stones. So here we measure the mass of the stones. It is 30 grams, for example, and then we put the water up to 40 cubic centimeters, and then we put the stones inside of that cylinder, and with water plus stones will be, the level will be at, let's say, at 60 cubic centimeters. So now if we take a difference, 60 minus 40, it will be 20 cubic centimeters. That would be the volume of the stones. Now let's calculate the absolute error of the volume. Since we use this subtraction, we need to use this equation. We need to look at this case, and we need to use this equation to calculate the absolute error. So as you remember in the previous slide, I mentioned that to calculate the absolute error of scale, we need to divide the minimum scale division by 2. So here the minimum scale division is 1 cubic centimeter. So the absolute error for this volume of the absolute error for this volume would be 0.5 cubic centimeters, and for this one also 0.5 cubic centimeters. Since we use the same graduated cylinder for both cases, so the total absolute error would be 1 cubic centimeter. And to calculate the relative error, we are going to use this equation. We simply divide the absolute error divided by the volume of the stones. So it will be 0.05. Now let's calculate, or let's check the absolute error of the mass. It is 0.1 gram. How did I find it? How did I find it out? On this device, actually on the back side, there is information about the absolute error, and it says below 200 grams, the absolute error is 0.1 gram. So since our stones only 30 grams, we can use that value. Some electronic device may not provide absolute error, but they may provide the accuracy class. So by that accuracy class, you can Google and find out how much is absolute error for that class, and you can use that value in calculation. So to calculate the relative error for the mass, we are going to use this equation. We divide the absolute error of mass by the mass of the stone. So mass of the stone is 30 grams, the absolute error is 0.1 gram. So the absolute, the relative error for the mass is 0.03. Sorry, 0.003. So now let's calculate the density of the stones. So we simply divide mass by volume. And the answer is 1.5 gram per cubic centimeters. Now we can calculate the absolute, the relative error for the stones using this equation. Since it's a division, here we divide mass by volume, so it is this case. So we are going to use this equation to calculate the relative error. So we simply sum the relative error of mass and relative error of volume, which we already calculated. So the relative error of mass is 0.05, we calculated here, and the relative error of volume is 0.003, we calculated here. And the relative error of the density will be 0.053, or if we multiply by 100, it would be 5.3%. Now we can calculate the absolute error of the density by this equation, and the answer is 0.08 gram per cubic centimeters. So this is the total answer as it should be written as the density equal 1.5 plus minus 0.08 gram per cubic centimeters, and it is the error is 5.3%. So this is how these kind of problems are supposed to be solved. Thank you for watching. Subscribe for more science videos.